Okay. Okay. So yeah, we completed the first two modules already. Unit 1 and Unit 2, the introduction to GMP and also the introduction to food safety. Okay. Sekarang kita masuk Unit 3, which is introduction to HACCP. Okay. So just now I explained to you GMP governs the premise. HACCP handles the process. Okay. HACCP stands for Hazard Analysis and Critical Control Points. Okay. So what is it actually? Okay. So yeah, this is what how the hazard system looks like. Ni bawah MOH, Ministry of Health, right? Ni innovation dalam Ministry of Health. Okay. Ni bawah SIRIM dia kan tak macam ni. Okay. No, this is we don't use this because we are not under SIRIM. Okay. Ni MOH ni SIRIM, yang tu just in general lah. So, hazard analysis and critical control point is an internationally recognized science-based food safety system designed to prevent, reduce, and eliminate potential biological, chemical, physical, and allergens on food safety. Okay, that's why I'm explaining that the 4 things that we will monitor right at these 4 things. So every process we will monitor these 4 things. Okay, hazard analysis. Okay, what is it? Basically, a systematic approach to identify and assessing hazard and risk associated with food operation and defining means of the control. Okay, apa kita buat is basically proses, setiap proses tu kan, kita akan buat hazard analysis. Kita akan list out proses, what's the potential hazard, macam reaction tadi lah, bawa raw material kan, okay, kena physical apa, benda asing macam dalam minum, okay, chemical apa, hujan, biological apa, contamination. Okay, so kita kena list out, right? And then critical control point. Okay, basically a step to control measure. Okay, control point is a control measure how to prevent that hazard in affecting your product. Okay, so control point ada dua tau. Kita ada satu control point, satu lagi critical control point, CP and CCP. Okay. So yeah, the control point to prevent, eliminate or reduce to an acceptable level. Certain hazard kita boleh reduce to acceptable level. Okay, example macam heavy metal lah. Okay, heavy metal, arsenic. Arsenic probably no. Sebagai diri sendiri, panas ni. You should probably dispose of product. Iron lah. Iron mesti no regulation. Chromium. Yeah, chromium is mostly this one. Chromium regulation is I think 200 ppm. 200 ppm limit. Okay. So bawah 200 ppm still you can accept. Okay. So principles of HACCP. Okay. So bila kita discuss pasal HACCP kan, okay, this is actually very common tau. If you go to any food industry, they can follow the same system. Okay, under HACCP. HACCP ada 7 steps. Always the 7 principles of HACCP or 7 steps of HACCP. Okay, you will always follow these 7 steps, right? So if let's say you want to go food industry, you can say lah, I know the 7 steps of HACCP. So these are the 7 steps. Okay, 1, will conduct a hazard analysis. Always the first one is you map out your process. Okay, the map process kita akan conduct hazard analysis. Okay, that's why I explained the 4 steps. Okay, next you determine the critical control point. Okay, based on your hazard. Hazard boleh control, kita letak control point. Hazard tak boleh control, kita letak critical control point. Okay, establish critical limits. Letak critical control point, kena ada limit. What's the acceptable limit? This is where our AQL comes in. Acceptance quality limit. Okay, and then we letak monitoring procedure. Okay, we dah prepare 3 tu kan, letak monitoring procedure. How you monitor? Weekly, monthly, yearly, hourly. Okay, establish corrective action. Okay, if let's say your control point fails, what's the corrective action? Okay. You establish verification procedure. You verify your yang letak tu kan berfungsi ke tak. Okay. How? You stress test the system. And finally, establish a record keeping and documentation procedure. Okay. So, how's your documentation? Macam mana you record your control point? Okay.
Sebab tu yang metal dekat sim raja tu kita standard as CCTV juga.
It's a CCTV. Okay. Yeah, I'll do it. Stand on that. Right? So clear? Okay. Now I'm going to go each and every one of it in detail. What's the requirements under it and how we do it here. Right? Okay. Number one, conduct hazard analysis. Apa tu hazard analysis? Basically, hazard analysis systematically identifies and assess potential hazard specific to food product, okay, and production process. Okay. Dia systematically identify, because you identify each and every hazard yang boleh or potentially can occur. Okay. Allow for effective development and safety measures to mitigate a hazard. Okay. And dia akan identify the biological, physical, chemical, and the potential allergen. Okay. But now it is allergen. So this is where it gets tricky for us. Biological, physical, chemical, we can do it.
Yeah.
Allergen for animal feed. How do you determine allergen for animal feed? Because animal allergen is not similar to human. Okay. But pet food, yes, we can do it. Okay. Because anjing, kucing akan ada allergi. Sebab makan dia akan setakan geru-geru kalau busuk jatuh. So dia macam human juga. Dia ada nut allergy. Okay. Like the example of dogs, dia tak boleh letak coklat betul. So dia orang tak digest coklat. So that's a bit different from human lah. Okay. So you identify semua ni. So let's say production you ada pakai coklat. Dah ni lah. Dah tahu lah potential allergen. Okay. Okay. How you do it? You begin by identifying the products and its associated process. So that's why the key thing that whenever we do is we always map out our entire process, the process flow, step by step. Okay. So I put a lot of effort on my time to do the process flow. Next, you determine the contaminants. Okay, physically, any foreign material, panis material. Okay, benda-benda asing that can cause physical injury to consumer. Okay, example kat sini glass, plastic fragment, metal fragments. Okay, it can also include biological contaminants such as nails, skin, hair, or insects. Okay, we are insect industry, to produce insect nail, but still one of our physical contaminant is insects. Okay, mites, kumbang, pori. Okay. Yeah, also notice this nails, skin, and hair. Sebab tu kita ada gowning procedure kat sini. We use that ni. Okay, and always tell people don't wear bila kerja kat ni kan, jangan pakai cincin, ring atau jam tangan. Sebab tak nak benda ni jatuh dalam ni, dalam produk. Okay, manis, pakai jam tangan jatuh dalam tu. Hantar pergi Korea, rembek sana jumpa pakai jam tangan. Okay. Chemical. Okay, any compound derived naturally or produced synthetically that could be poisonous to consumer. Okay, bleach, pesticide, grease. Okay, include biologicals again such as hormones and feed additives. Okay, feed additive kita pakai kat sini tau. We use feed additive. Okay, but we have a limit tau how much we can use. Right? Does anyone know what's the limit? Berapa limit? Kau perlu tahu, pasal saya yang bincang dengan ni.
Berapa persen dia mixing machine?
Biasanya 8 kilo dengan
Berapa persen? Tahu?
Yang 1 kilo dia 1 ml.
10 ml okay lah, that's right. Okay. Kita punya limit BHA, okay, yang Codex tu bukan BHA tau. Dia BHA dalam PG. BHA dalam polyethylene glycol. Okay. So kita punya limit ialah 0.75 mg per kg.
Ni pure.
Ni BHA.
Belum baju.
So setiap kg produk kita nak tambah 0.75. Apa kita buat? 0.75 kita tambah dalam 1 liter PG. Ni yang cecair tu. Yang kita tambah.
Maksudnya dia banyak sikit.
This one only for oil or protein powder?
Everything, both. Okay. Kita pakai 0.75. International limit is 150 ppm. Okay. This is maximum limit allowed. Depends lah. Most countries follow this lah. Tapi ada setengah country can go up 300. But that's the max lah. Anything above that is danger.
Why we take at 0.05?
Good question.
Cost.
We started with 150. Sebab kita punya limit 150 kan. But people started complaining yang produk kita bau chemical. Okay. And then we did study our shelf life study. So kita try dengan 0.75 dengan 150. Okay. And kita nampak 75 dan 150 dia punya shelf life even lepas 9 bulan sama je. So in order to save cost lah, we just go to 75. Okay. Biological hazards caused by microorganisms often associated with failure of a process or step. Okay. Kalau ada microbial contamination dalam produk, that means your process is not working. There's a flaw in your system. Okay. That's the reason why our validation kita pakai Clostridium. Kalau ada Clostridium pada produk finished good, that means our system is completely gone. There's a critical failure there. Okay. Even not only this, even DBS government research is it's called a validation microorganism. They use to validate. And finally, allergens, compounds used in food and feed that will cause allergic reaction to consumers. Okay, example peanut, okay, milk, dairy, eggs, meat. Interesting data here. I ever wondered why our raw material kita tak pernah ambil anything related to milk or egg, anything related to animal product.
Salmonella.
EU requirement.
Why EU recommended that? Why EU put such a regulation that you cannot use anything from animal based? Even milk, okay, we consider as it's from an animal product. It's from an animal. Okay, why? Because of these things lah. Salmonella contamination.
So vegetable based meat okay kan? Macam soybean.
Yeah. So it has to be 100% vegan, not vegetarian, vegan. That means no animal products at all to be used. So it's very critical in SCM. You cannot bring bread that contains milk or any product that contains egg.
EU.
But why wheat?
Allergen? Some people are gluten intolerant.
Anyone who heard the wheat person?
Animals also almost milk also.
Itu makanan. Wah, siapa sih?
Okay.
Boleh kita tu.
Roti kita tak ada susu dengan telur.
According to according to SCM tak ada.
Ni kosong. Tapi saya maybe thinking of bread.
I was when they started using that and also noodles kan, dry noodles. So I was saying, dry noodles is something just eat kan, nak buat. So I was like very curious though, betul ke? But they managed to produce a letter lah, kata dia orang tak ada. So they give actual letter that they certify there's no animal product. Okay. Now EU regulation, the thing is kan, dia tak kata kita tak pakai. Okay. Kalau kita boleh justify origin of that material kan, kita boleh pakai. Tapi dia ada separate form, you know. Okay. They call it form 3 something lah, NX3. Okay. Under that, you need to justify origin of that material. In terms of, let's say, use milk, kalau pakai susu, where that susu comes from? Ambil dari lembu mana? You need to justify the entire supply chain tau. Now, if it's a normal product, yes, you can do it. Tapi kalau macam kita, which is we take sampah, pergi tanya supplier suruh bagi original kan, dia akan kata, ya, you know what you say lah. Kau dah ambil sampah dah, dulu lagi.
Komen nak banyak je.
So that's why we decided to put a rule. Okay, fine. To avoid all this, no animal products.
Sorry, if let's say we separate raw mat and CM in different entity, we just and different producers, but we just put the border like establish our raw material and the silage only. With that, they need to check until that extent. Even the
Because your silage is being prepared by the raw material, so it's up to that point.
until that point, right?
So the source of the because in our process kan, silage is not the first step tau. The incoming of the raw material is the first step.
That's why I ask you if let's say we separate into different.
We can't because silage is being produced unless we buy silage from someone else. Okay?
Yeah.
We buy silage from someone else, yes. But the person we're buying from is the GMP.
Yeah.
Okay.
Kejap apa ni, kalau macam kita tadi animal sources tak boleh kan. Kalau sebab kita macam pernah fikir kita ada banyak waste lalat mati, so nak gunakan sebagai part of the feed. Kalau BSF bagi kita makan, still DNA lalat juga yang keluar kan kalau buat analisis. Ada problem tak?
You mean use our larvae?
Dia dengan dead plant sebagai makanan larvae.
Sebagai makanan larvae.
Dan sebagai itu saja.
Point.
Anak makan rumah.
Because it's technically not animal origin, it's an insect origin.
Oh.
Dan sama we recycle our own waste.
And it's the animal that we are producing, you know. So that means we are controlling the process. So we can do anything we want on that. And that way we can justify it.
Oh.
Okay, next. Okay, now we have done hazard analysis. Dah siap. Kita dah identify semua hazard kita. Okay, dah settle semua. Kita ada total 80 proses including 20 raw material. Kita dah prepare semua. Proses flow, buat hazard analysis, all dah. Next, we need to determine control points. Okay, we identify several steps which are dangerous to us. Okay, how do we do the control points establishment? Okay, so critical control point is a point in production which controls is applied to prevent, eliminate or reduce the safety hazard. Okay, so dalam ni kita ada dua, control point dengan critical control point. Okay, so what's the difference between these two? Control point. Okay, now both we identify melalui risk analysis. Kita dah buat risk analysis, kita dah tahu apa hazard dia, kita dah tahu control point kita. Okay, now we need to determine ada control point atau critical control point, right? So control point reduce the likelihood specific hazard is occurring. Okay, dia tak eliminate tau, dia reduce. Okay, whereas critical control point absolute control over the hazard. Okay, if your critical control point fails, your product fails. Tapi your control point fails, you still got more steps to control it. Subsequent steps to control it. Okay, so that's the major difference between these two, right?
The government also got things that critical point, if it's more than few fail, then it's not a good thing.
Depends. Later I'll sort of limit how it works. Okay. Failure, okay. Control point. Failure does not mean product is unsafe, as I said. If your control point fails, ya ada lagi step kat depan yang boleh control. Okay. Critical control point. Okay. Failure indicates product is unsafe. Your critical control point fails, that means your product is unsafe. You cannot export it. You cannot produce it. Okay. Maybe, okay, control point may be measurable or could just be observable. Okay, you may measure it, you just observe it. Okay, but critical control point always measure with critical limits. Okay, you have to have a critical limit. Okay, what's the maximum is allowed. Okay. Control point you may or may not need validation. Okay, apa itu validation nanti I akan explain. Because validation is one of the critical points in and we also do our own validation now. Validation study is one of the most difficult and most expensive studies we are doing. Okay. Critical control point must have a validation. Okay. And control point verification is required by the form of checklist. This similar for both lah. If whenever you have a control point, a critical control point checking that, you can verify. Okay. Now, example of control point and critical control point. Okay, I'll take area 6 lah. I think most easiest for us to understand area 6. Okay, area 6 kita buat proses kita. Lepas oil press, kita masuk milling, kita sieving, betul tak? Okay, sieving is control point. Okay, sieving is a control point because they sieve at a particular mesh at 1 mm. Okay, so they can filter out benda-benda yang ni. Okay. Okay. Tapi kalau sieving fail, okay, atau metal masuk kan, we still can control that by our metal detector. Okay. So if the sieving fails, they still have another control point there. Okay. But our metal detector is a critical control point. CCP. Okay. So metal detector fail, there's nothing else stopping your product from ni dah. Memang tak boleh dah. That's the final step. That's the difference between control point and critical control point. Okay. In any industry lah, in the food industry or pharmaceutical industry, okay, always metal detector is automatic CCP. You don't even need to do validation. It's automatic CCP. So this is how you determine lah. Decision tree. Kena dapat CCP atau CP. Okay. Hazard analysis. Is there a hazard? Yes or no? Okay. No, control as just quality issue. No hazard. Example, to be raw material impurities. Okay, that's not a control point. It's just that it's there for the sake of being there lah. Okay. Kalau ada benda asing dalam raw material, apa kalau berlaku? Cost of emission dia besar. Tapi tak ada effect dalam produk. Okay. So it's not a hazard. Yes. Risk assessment. Is it a significant hazard? Yes or no? No. You control as PRP, ORP or CCP. Okay. You control as PRP, as prerequisite program. Letak. What kind of control you want to do? Okay. ORP stands for Operational Requisite Program. OPRP. Okay. Now, if you say yes, it's a significant hazard. CCP determination, is it managed as CCP? Yes. Example, steam dryer kita dengan metal detector. These two are CCP. Okay. So then you put as critical control point. Okay. For us, we ada dua CCP kita. Okay. Our first CCP is steam dryer. The reason why we put steam dryer as CCP is because we want to control micro temperature. Okay. Because that's the only machine that has a significant temperature system. Okay. Then we can control lah. Our oil price and all that, we cannot control the temperature. So we cannot put that as a CCP. Okay. But a steam dryer, you can put a CCP and you can manually monitor it. So that's why we determine that as CCP. Okay. And then the next one is metal detector. Okay. Pernah tengok? Tahu tak apa ni? Ini saya ni tahu lah ni. Dia sama dengan high-rank je. Memang sama dengan high-rank sistem dia. High-rank safety, tapi HACCP dia untuk food safety. Okay. This is a risk assessment matrix. Okay. Whenever we do hazard analysis, kita kena letak tahu apa tu likelihood and severity. Okay. And then based on that, we determine how risky it is based on the risk assessment matrix. Okay. The two things we always put is likelihood and severity. Okay. Severity is either ini kan depends lah. Sometimes some people just do 3, some people do 5. Kita pakai 5 kan. Kita ada 5. 5 kali 5 kan. Okay. Some people just do 3 by 3, some people just 5 by 5. Depends on what. Okay. Kita letak negligible, minor, moderate, major, extreme. Okay. Alright. Negligible severity, that means we can just ignore it lah. Doesn't matter too much. Okay. Extreme, critical product failure. Okay. Same way we do likelihood as well. Okay. Very unlikely to occur or occurs frequently. Okay. Tiap kali kita produce produk tu akan berlaku benda tu. Kebarangkali berlaku. Atau setiap kali kita produce tak mungkin sekali lah 16 kali dia berlaku. So based on that kita akan letak dia punya ni lah. Kita akan target. Okay. So it's always this times this get this data. Right? Normally kalau dia fall dalam yang green zone ni kan, that means this is a very minor ni lah, tak critical sangat. Okay. So you can just do a normal checking atau the monitoring procedure pun tak frequent sangat lah gitu. Okay. Yellow is pretty dangerous lah. That means you need to more frequent ni, but it's still not critical yet. Yeah. Merah is critical product failure. Okay. That means it's always happening, and it's happening at very high. It's always extreme, and it's always happening at a very high frequency. So this is a critical failure. So this is how we set the likelihood rate, our hazard analysis. We actually have this, for we have one for high rank, for safety, and we also have one for food safety. Our HACCP plan. Our HACCP plan is about that thick, Total 160 pages. Even for all the raw materials you do, every single raw material we have. Okay. So clear on the answer. So you already know your hazard. Okay. You have already set your critical limit. Next, you need to do is determine the critical limits. Okay. Apa? Okay. Critical limit is the maximum or minimum value which safety hazard can be controlled. Okay. Ini yang critical limit kita lah. Alright. It is specific value to which the hazard must be controlled. Okay. Like some examples here. Temperature and pressure and time at 133 degrees, 3 bar, 20 minutes. You know what is this, right? Those who work in lab know this now. What is this? Okay. Right. Mass treatment mixing time 6% at 30 minutes, 300 rpm at 90 degrees. Okay. So this is our critical limits set lah. Okay. So how do we determine the critical limits? Okay. So macam mana kita nak tahu critical limit kita? Right. Satu, kita akan buat regulatory requirements or guidelines. Okay. Example kita kan, our kita punya dekat steam dryer. Okay. Our critical limit is cannot have presence of Clostridium, cannot have presence of Salmonella. Absent betul. Okay. That means you need to have a system that is effective enough to eliminate it. So that's basically a critical limit. Why? Government regulation. Very good. Government regulation. Okay. Number 2, scientific research. Okay, that's why our R&D team doing all the studies to set the critical limits lah. Okay, so but then in our case R&D and research is almost in normal limit lah. Right? Example like protein content, CP specific value dalam produk segmen kan. Okay, our limit is 50, not bigger than 50, but then we have the classification. Okay, between this and this is this grade, between this and this is this grade. Okay, product characteristic. Product perishable. Okay, so we can only store for 7 days. That's the limit. Okay, so we have product details and then we have trade concern. And finally, process capabilities. Tahu tak apa tu process capability? Okay.
Macam proses tu dia boleh eliminate dekat apa tu?
No, this is machine limitation or process limitation. Okay. Example, you buy a oven that can only goes up to 100 degrees. Okay. But then you need to eliminate a product that is 144 degrees, 120 degrees, let's say. Okay. But cannot because your machine limitation is 100 degrees only. So how do you eliminate that? You increase the time. So something like that. It's just a crude example lah, but you get an idea, right? Okay. So that's how we set up basically. Okay. And the most common critical limits in any food processing. Okay, this is standard tau. Most food processing akan follow this basic critical limit stuff. Selalu nombor satu selalu temperature je. Because why you want to control micro? Micro control is always based on temperature. Temperature and time, you always play these two. Okay? You lower the temperature, you increase the time. You lower the time, you increase the temperature. If you cannot do both, you increase the pressure. Okay? These are the two things. Nombor tiga, pH level. Okay, science kita pH level. We always mention pH kan. That's one of the limit lah. Moisture content. Okay, we have moisture content for our product. Our hydrate cannot be exceed certain moisture because why? It can attract microbes to come in. So we always maintain. I think our hydrate level is segini.
Hydrate is below 20.
Windows 7 is what? Utilities. Okay. Microbial limit. Okay. Sorry, I'm a bit sleepy, I know. Guess it's stress a bit. Okay. Microbial limit. Kita ada juga microbial limit tau. Okay. Like in our case, Clostridium and Salmonella is absent, but Enterobacter. Tahu tak apa tu Enterobacter? E. coli yang bagi senang perut tu. Okay, one of the example of Enterobacter lah. So dia ada classification bahan besar lah Enterobacter tu. Okay, Enterobacter should be below 300 CFU in 5 samples. Okay, so between 30 below 300 lah in 5 samples. So that's our limit. We can exceed that. Okay, allergen threshold into allergen product. What's the limit of allergen? And finally, either weight or size. Okay. That can be a limit also. This is more common in frost lah. Okay. If your weight is higher, that means you know either it's bad or something wrong with the product. Okay. Yeah, let's keep this one. Okay, so you understand the critical limit setting already, how we do the critical limit setting. Okay, so whatever we are explaining here, actually what we do here, you know, semua ni kita buat di sini, and we have the evidence for it. Okay. Next, okay, so you've done your hazard analysis, you have set your CCP, okay, dah. Nombor 3 dah set critical limit. Sekarang nombor 4, kita kena define monitoring procedure. Kita dah ada critical limit. How do we define our monitoring procedure? Okay, so monitoring procedure is an activity to ensure that every process is under control. Okay, and the measurement is taken, the frequency and who is responsible are taking it. Berapa kali nak check benda tu? Okay, and then siapa akan bertugas untuk ambil data? Semua ni kita kena define dalam kita punya procedure. when I say responsible people, I don't mean name now, the position. It's going to be a QC assistant, it's going to take it. Production supervisor. Those kind of things. Because people can change, but position will remain the same. Okay. So how do we determine the frequency? How do we determine? One, based on risk assessment outcome. Okay, kita buat risk assessment kan, tengok tadi nampak yang severity matrix tu kan. Kalau dia severe sangat, bahagian merah, we need to increase the monitoring procedure. Kalau dia hijau, maybe we can do a bit longer, tak issue. Okay, the nature of the CCP. Okay, example like microbe lah, usually microbe or metal untuk metal detector the product. Yeah, that one all needs to be every batch to check. Okay. Potential risk associated with the CCP. Kalau the risk is higher, your monitoring frequency must be higher. Okay. Other specific requirement under the HCCP plan. Okay, sometimes ada juga benda tu tak critical sangat, tapi kita increase because kita tengok benda tu kerap berlaku. Okay. So that means something wrong with the procedure juga. We need to monitor the result, so kita akan tukar. Requirements of critical limit and process variability. Ni process variability. High variability, high monitoring. This is something that we are currently struggling with because proses kita sangat variation sangat tinggi, especially our CCP. Okay, because temperature cannot be controlled.
Can be monitored, but cannot be controlled.
So for that, we need to do constant monitoring. That is why we do constant monitoring of temperature. I think what we do every day. Yeah, every day. Every day once per shift kan.
Yeah.
Kalau kita boleh control temperature, that means we can control, we know that's right. We don't have to do every day. Just pass it maybe once a week or once a month. Okay. So when we do monitoring method, okay, when we set the monitoring time dah kan, we need to set the tools that we're going to use and the procedure how to do it. Okay. Use appropriate tools and procedure to monitor CCP. Example, temperature. Dia kena monitor pakai the appropriate tools. Okay. Now this pernah kena tau dengan DBS dulu. Okay. So essentially what happened was kita tengah pergi audit kan kantor. Kita punya CCP yang ni steam dryer. Malangnya steam dryer kita tak boleh monitor dalam sebab dia kena check dalam chamber temperature tau. To ensure. Okay. So we cannot, dia tak boleh masuk kan benda tu. And also the machine is so big. How do you macam nak monitor temperature? So apa kita buat? Kita letak product core temperature that comes out monitor with using thermometer, okay, at this particular degrees. So when we say kalau dia dah produk keluar dalam 80 darjah, that means the core temperature is around 120 degrees. Okay, that's how we justify lah. Okay. Dia tanya kita tahu macam ni monitor. Mana data? What is the tool you use? Initially we were using that infrared thermometer tau. Ini dia didn't accept infrared thermometer. Dia kata tak boleh kau monitor pakai ni. And we had to justify that infrared thermometer is properly calibrated and can be used. Only then they accepted.
Calibration.
They actually wanted us to use the probe temperature. So that's why all of this kan, the tools kita kena justify tau dalam kita punya plan, plan. Okay. Microbiological, regular microbiological testing, either in-house or third party. Sebab tu kita selalu hantar testing third party. Okay. Ensure all equipments are frequently calibrated and accuracy is maintained. Okay. Calibration check must be done regularly. Okay. Semua produk kita perlu di-calibrate, okay, and must be properly, must ensure lah dia accurate lah.
Semua tool kita kena
Semua monitoring tools. Okay, that's why we have a calibration plan. Kita hantar setahun sekali ke third party because this is a verification procedure. Okay. implement of effective sampling plan. Ensure that samples are collected in a proper lot. Untuk finish good, kita kena properly sampling. Sekarang siapa buat sampling?
Mana?
Siapa buat sampling kat hari ni? Cik. Ni kau buat?
Nanti
Diorang kan, kita orang sama.
Bila kau ada habis sampel ni?
Ada.
Tapi you ada ajar dia macam mana nak buat sampling. You tahu kan sampling plan dia? So dia kena train.
Macam after CV, after DD semua kan.
Dia punya
Okay. Right? So clear so far? Okay. Dah ada action plan, dah ada CCP, dah ada critical limit, dah ada monitoring plan. Next, nombor 5, kita kena buat corrective action. Okay. From time to time, your CCP will fail. There's no such thing that CCP doesn't fail. Okay. Or your corrective plan is not working. It will happen lah because you're dealing with humans kat sini. Okay. Ada masa orang akan buat kesalahan. Okay. You cannot expect 100% perfect. Okay. So when this occurs, you kena ada corrective action. Okay. So that's basically how we do this. Okay. When a deviation of critical limit occurs, right, corrective action must be initiated. Okay. Corrective action process is a process put in place to prevent health hazard and establish corrective measures to eliminate. Okay. Importance untuk corrective action, kita can prevent unsafe product. Okay. Mitigate risk associated with deviation. Okay. Minimize economic impact. Compliance with regulation. Continuous improvement. Continuous process improvement. Okay. Your machines are getting old. Your tools are getting old. People are getting more and more complacent. Okay. The same people are doing work kerja sama setiap hari tau. Mistakes will occur. Right. So continuous process improvement is so that's why you have a corrective action plan. Okay. And also consumer confidence. Okay. So how do we do corrective action? Satu, kita akan identify the deviation of non-conformance. Okay. How? Through monitoring procedure or immediate response. Kalau CCTV fail, you immediately stop the process. That's why QC is very powerful. Yeah. If your QC feels that the process tak betul, they can stop the procedure and no one can question them. Why? Because you are not following the instruction. There's a critical warning. Okay. So you stop the procedure, you isolate the product, and then you do investigation. Setiap deviation must be investigated, and you must do a root cause analysis. Okay. Dia panggil CAR, corrective action. Corrective action. Okay. Yeah, and then you do the root cause analysis. You investigate, you do a root cause analysis, RCA. Okay. Here you use all your tools lah. Siapa-siapa yang masuk Lean Six tu akan tahu lah benda ni. Siapa masuk LSS? Siapa masuk LSS?
Mana ada ni kita orang ni.
So this is something for you to learn lah. These are all the RCA root cause analysis tools lah. Dia ada banyak 5 whys. You do the why analysis. Okay, dia panggil technical why analysis. You put the cause of the product, the issue, why. Example, there's impurities in your raw material. Why there's impurities? Supplier never check, never give a proper answer. Why supplier never give? Okay, what's his issue? Why that happened? You go so far until you find the root cause there. Okay, this is the trigger of the problem. Okay, and then you do the root cause rectification for that root cause. So why analysis. Second is fishbone analysis, Ishikawa diagram. Anyone pernah deal dengan Ishikawa? You know what's Ishikawa diagram?
Yeah.
What do you monitor in Ishikawa?
Couldn't remember during my degree time I did study about that.
method, material.
Yes, predicate lah. Man, method, material. Okay. Asal ni tahu ya? Cakap apa? Man, in sense so, teachers is also the same thing again. Man, method, material, measurement, environment, and apa lupa. There are 3 lah. So that means with this all the main title, what's the potential effect yang can contribute to the issue? Okay. Oh, failure mode FMEA. Yeah, this is the most paling how to say paling robust punya lah ni. Okay, FMEA. Failure mode and effective effect analysis. Okay. So dia lebih kurang macam kena hazard analysis tapi dia akan masuk lagi detail. What's the potential for each steps kan? What's the potential failure mode? Yang what can go wrong and how to control it. You list out everything you can go on, can go wrong. So that's why your FMEA is really very big to plan. Banyak SM tech industry use this. SMT, semiconductor. You look at FMEA. Okay, medical device what can look at FMEA. Medical device. Okay. So now you determine the root cause today. Next you do what? You take immediate action, corrective action to correct the issue. Okay. Based on the outcome of the root cause analysis, develop a corrective action and take immediate action. Okay. Immediately you need to rectify it because it's a failure, right? Lagi lama you dah drag lagi lah produk kami keluar sebab QC dah stop proses. Right? And then you document the action. Lepas you habis rectification, you kena document benda. Okay? You need to have a robust report of what your deviation is, what's the corrective action you taken, okay, and how did you implement it, and what's the outcome of that. And you have to have a review. Maybe 6 bulan sekali you pergi review it, your corrective action berfungsi tak? Oh, 2 minggu sekali pergi monitor. That's how you do a root cause analysis. So these are all the steps of deviation. So as tadi katakan GMP, deviation is very important. This is why lah. It's a very big title. Okay, so done hazard analysis, done CCP, done monitoring process. Okay, you've done your corrective action. Okay, then you've done your what?
Your limit.
Your limit, yeah. You done your limit, you done your corrective action. Number 6, you establish verification procedure. Okay, you need to verify your CCP is correct or not, or your limit is correct or not.
Every time have the limit.
That's verification procedure. Okay. Verification and validation ensure that HCCP plan is working as designed and is successful in producing safe product. Okay. I'll tell you a story about this HCCP validation. Like we cannot answer. Okay. So how you validate? Okay. You either do audits. That's why we have internal audit. Okay. Or you review the system, the equipment and calibration. Once a year, you call third party datang calibrate kan. That's a verification procedure. Okay. Product testing, kita hantar pergi lab punya produk environment tu kan. That's verification procedure. We do it once every quarter. NT. We do full product testing every quarter. Okay. So that's our verification procedure. Okay. Purpose is to confirm your CCP. Okay. You want to ensure corrective action is effective in addressing deviation. Okay. Validate your HCCP plan. Okay. And provide evidence and compliance to food safety. Okay. So how you do your verification? Visual inspection, sampling and testing. Okay. Document review. Kita review kita punya dokumen kan. Right. Audit. Internal audit, site audit. Okay, how frequent you do audit? Sebab tu sekarang kita tengok audit area by area. It's a verification system lah. So siapa auditor? Nombor dua. Okay. Dia buat apa? Dia akan ambil SOP, dia akan pergi ke step, dia akan check. Okay, you kata you ambil press kit, you masuk dalam milling machine sebelum pukul 12, sebelum 12 jam. Buat tak? Buat. Itu deviation tu. Okay. Alright, so internal audit. Then third party audit. Third party audit is very important because of this lah. Kita punya surveillance audit semua tu kan? Yeah. Is to verify that the system is working. Right? The system that we establish is working. And finally, process monitoring. Continuous monitoring the process to track data. Our steam project lah, FG project. That thing has been going on for 4 years, you know. Because so much amount of data on that. Yet still no proper rectification. Okay. Frequency. The frequency, setting up the frequency is based on, again, the CCP lah, right? And how critical it is, right? The frequency will depend on the hazard plan, the CCP, and the process, the risk level of the process. Okay, kalau risk tinggi, kita tak lebih tinggi. Okay. Some verification such as routine monitoring. Example, kita punya steam dryer, disebabkan kita tak boleh control temperature, okay, the risk of the thing failing is very high. So we put monitoring temperature every day. Okay, example. Okay. Yeah, verification is an ongoing process and not a one-time event. That means you cannot like buat sekali okay lah. Benda tu berfungsi dah. It's an ongoing. Selagi company tu berjalan, selagi tu kena buat. Or selagi mesin tu berjalan. Okay. Validation. Yes. Verification is used to verify. Validate is something else. Validate is you need to validate your CCP. The validation basically says your CCP is working. Okay. Now validation is very critical now. One of the most important you go to any company related to GMP atau HCP kan, food, medical device or whatever kan, validation is the most paling nombor satu. In fact, certain companies, they have their own validation department tau. And they have like their own validation engineer, validation scientist, validation team that actually does the validation, only validation. Okay, Biocon, the most they have like almost like I think about almost 200 people working on validation already. With their own ring. So it's sangat penting ni, validation. Because validation will ensure that your product process
validation team kan.
Dia ada validation team dia sendiri. Okay. Right? Okay, the process, okay, validation was basically validation. Validation is basically a process of obtaining evidence that the HTC system is effective. Okay. Tugas dia ialah to ensure that the critical limit, monitoring procedure and corrective actions are sound based on scientific principles. When we say about scientific principles kat sini kan, what do you mean by scientific principle? In science, what do you do?
Testing.
Why do you do testing? In lab, okay, when you do your master's set, what you do and how you do it?
Check parasites in boots and then take
Yeah, how do you do it?
draw blood and take blood sample.
Okay, what do you call that process? You collect
data.
data, exactly. When you do a scientific principle guide, you can collect data. You collect your data and you do a conclusion based on your data. That is called a scientific principle because you're doing a conclusion based on actual data and actual okay. So you do a conclusion based on that. So that's how you do a scientific principle. So similarly untuk validation you kena buat benda sama juga. You need to collect your data and you need to validate based on your data. That's why most places have their own department doing it. Because it's a continuous process company. Okay. They ensure HACCP system are capable and constantly producing safe food product. Okay. We actually have a case with our own validation now. Our own system kat sini. So essentially, bila first time kita nak pergi GMP kan, we didn't know, we didn't set our CCP tau. Kita tak ada CCP because we didn't know about the EU regulation. We all blindly was doing it back then. Okay. So bila DBS datang terus kan, first thing dia tanya kita, mana your validation data? I still remember like it was me, Nick and Nick and Charlie in the meeting during the audit lah. Okay, I was looking at Nick was looking at me. We were like, what validation what is? Then she asked, what's your CCP? And then we said CCP the steam dryer. You have a CCP, where's your validation data? Okay, we didn't have the validation data. We didn't know about validation data. Okay, our consultant didn't brief us. Right? So that's when we found out, you need to actually validate the CCP. So what we did, okay, kita buat dua. Satu, kita buat process validation dengan satu lagi method validation. Okay. So method validation kita buat apa? Okay, kita tahu requirement ialah Salmonella, Clostridium dengan Enterobacter. Tiga benda ni. Okay. So kita commission R&D team. Okay, untuk buat study di mana dia akan check, dia check multiple different temperature dengan time, treat the product, and what's the best temperature, best time to be implemented to eliminate Clostridium. Okay, so dia mereka buat study lah, mereka buat full scale study. Okay, based on that, they give a conclusion. Okay, dia kata 20 minit pada 90 darjah is enough. Okay, you can eliminate all the bacteria. Okay. Habis tu kita kena, that's method validation. So we validate the method. Okay, so we have scientific data to validate method. Next, we need to validate the process. Okay. Process validation is on site when we implement the method, how effective it is. Okay, so kita buat apa? Essentially we implemented the system dengan steam dryer kita. Luckily our steam dryer kan, it was going up to 40 minutes, you know. And the temperature was much higher lah. Chamber temperature 120 kan masa tu. Lucky for us, you know, okay, 120 for almost 40 minutes lah. So then we are confident lah the system. So what we did for CCP validation, according to EU regulation, kita perlukan 30 hari proses data. 30 hari consecutive proses data. That means kita kena run steam dryer 30 hari, collect sample, test untuk Clostridium, Salmonella dengan Enterobacter. 30 consecutive days. Kalau satu hari fail pun kan, CCP proses validation fail. Kena repeat.
Dan tiap bulan maknanya setiap hari lah.
For the 30 CCP lah. We actually commission the entire thing. So that time we just figures on that was previous team lah. 21, 21. Rezuan's team got method validation. They came up with a report, and then my team we did the data collection, and we had to send to our science. So our science did for the testing for us because cost effective lah. The time SGS was still new, and ALS was not. You know, Martin with ALS, right? Right? He was not very confident, so we had to send to our science. So we do. We have the complete data. They have a file of validation. You can actually go and have a look. Okay. And luckily lah, validation kan, it's up to us lah how often you want to do. Thankfully, we didn't change the process too much, so
You don't validate.
we don't validate back lah. But I planning to do a validation again next year. This has already been 3 years already. So I want to do a process validation again. Method tak perlu validate, but we need to validate the process. Okay. The whole exercise cost us that time was almost close to 20K. Over you. So yeah, that's how important validation is. So yeah, key steps in validation, scientific basis. You buat scientific studies, collect scientific data, and choose the limit based on that. Okay, macam how Rizwan buat lah. They buat multiple different studies and different temperature, different time, and then they buat conclusion. Okay, this temperature, this time is the best. And based on that, It's how we set the limit. Okay. Challenge testing. Yeah, this one something very interesting lah. This benda ni kan kita tak buat kat sini lah, tapi kat certain pharmaceutical company kita buat. My previous some company did this. This is also known as stress test. We intentionally spike the product to see if our CCP works or not. Okay. Expert review. Sometimes you can call third-party consultants to come and look at our system and just give best practices method or expert review. Sebab mereka dah ada 20 tahun experience kan. Mereka tahu okay, this thing can be done. Or scientific studies based on R&D scientific studies or any established paper, or we do historical data. That's the reason why we're collecting data for our steam dryer. So like we have 4 years worth of data. So we know this cannot work. We can use this. We can move this way. Okay, yeah. So you have done with all your 6 steps already lah. You've done your up to validation and sekarang. Lastly, kita buat record keeping. Okay. Documentation. Sebab tu selalu documentation sangat penting dalam GMP. Even HSC sama. Principal berapa tahun? 7 tahun ni? 5 kan? Okay. Okay. Documents must be available to prove that critical limits are being followed. Okay. So step lain kita buat critical check kan. Kita kena fill up the documents tu and then this to be verified. Okay. Documents such as HSP team, hazard analysis, monitoring of CCP, critical limit and corrective actions must be maintained. Okay. Kita ada kita punya food safety team, tahu kan? We have our own food safety team. There's about 6 members in 6 or 7 members in the right? Documentation can include hazard analysis, CCP monitoring, critical limit, corrective action, basically the whole thing lah. Okay. Employee training record, whatever we're doing right now, right? Okay, this training akan masuk dalam record. That means the employee has been trained under the regulation. Okay. Supply information, SCM. Okay. And traceability. Okay. They have approved supplier list, including sometimes we need the COA as well. Okay. Forms and templates should be standardized to record the GCP related information. Forms and standards must be numbered. Okay. Must have a document number and must be related to SOP. Tak boleh just create a document to use it. Okay. So whatever document you create, you have to register it under the department. Okay. Form should be easy, clear, and tailored for the specific needs of the organization. Okay. No point creating such a complex document when no one understands it, because you are not the only person going to be using it. Okay. Sometimes supervisors will be using it, sometimes operators will be using it. Kalau tak complicated sangat, operator tengok benda ni terus buang. Okay. So make it as basic as possible, right? And should contain all critical information, including date, time, measurement, action, and signatures. Setiap dokumen kena sign, kena ada date bila benda tu ni dibuat. Okay. Record keeping depends on the record, maybe hourly, weekly, monthly, or annually. Okay. Documents stored should be accessible for auditing and for verification purpose. Sebab tu kat sini kita apa? Semua hantar QA. QA supply. Sebab audit kita yang answer. QA yang bila audit kan. So easy for us to take out documents. Even though we are not a process owner, okay, kami bukan process owner tau. Kami cuma monitor the process saja. Okay.
We are
Like the process owner. Actually they need to keep the documents. But for us to make it easy, they just ask us, we will keep it. So during audit, we just keep it. Okay. You know, sometimes you need to go find them, they need to find person ganggu kerja kan. Okay. Yeah, so accessible manner. And then record should be maintained based on industry standard or as per regulatory requirement. Okay. some documents dia kata simpan 2 tahun. Some documents dia kata simpan setahun. Some like HSC document yang 5 tahun 5 tahun. Okay. And yeah, documents should be retained sufficient to demonstrate sufficient period to compliance with food safety requirements. What do they mean compliance with food safety requirement? Saya tahu. Apa maksud dia? Retain as long as the product
Consistent and consistent.
shelf life. Okay. The general rule of thumb is always kita kena simpan dokumen 1 plus 1. 1 year after the product expired. So kalau produk kita shelf life 2 tahun, kita simpan 3 tahun. Kalau produk shelf life setahun, kita simpan 2 tahun. Example, yeah, this is how a HACCP plan looks like lah. The heading complete ni kan. Okay, nampak? Dia semua. Process step, what's the potential hazard, what's the critical limit, what, how, frequency, who. Okay, example kat sini kita ambil metal detector lah, paling senang. Okay, metal detector, fragrance of ground metals in product. Okay, how detection, critical limit, any detection in metal product, stop. Which do not have a sana. Okay. Monitoring. How we do monitoring? What? Metal fragment. How? With commercial grade metal detector. Okay. Frequency. Continuous during production. Every time run jalan ke metal detector. Okay. By who? A trained and responsible plant employee. Okay. So here you can put production supervisor, operator, whatever lah. Okay. Corrective action. Whole product, stop production. Kalau fail, stop production. Okay. And then review maintenance record kalau seperti lah. Okay. Verification. Daily testing of metal detector. Okay. Daily testing of metal detector.
Verification lah.
Okay.
Bila tu bisa verification.
Our verification is twice per day.
Yeah, every shift lah.
Every shift. I don't know. Twice per shift.
Per shift.
Morning and afternoon. Okay. And finally record keeping, calibration log, metal detector, sensitivity check logs, semua dokumen yang terlibat dalam tu lah. So this is how we do a HACCP plan. You need to list out everything dalam kita punya plan ni. And it goes for every single step.
Yang nak stop tu berapa lama? Dia depend pada macam yang berarti berapa lama tu untuk
Kita stop as until the RCA can be completed.
Bila issue problem is rectified and we solve the problem, then balik ke run lagi.
Sebab kalau like example lah macam metal detector ni kan, suddenly run jumpa metal, then you need to stop the process now because there's critical failure metal. Okay, and then you need to investigate metal tu sekarang mana, what's the potential ni, okay, and then investigate and rectify the issue. Katakan like example sieving machine, metal datang dari sieving machine the mesh torn. Okay, so that means they need to rectify the mesh, put new mesh, only then we can start with the process.
kalau hafti lah, kalau days lah.
If it takes a month, yeah, they can do that.
Yeah.
Oh.
Like example, like our just a steam dryer lah. Steam dryer cannot go to okay, our steam dryer temperature kan letak 90 degrees. Okay, but suddenly we found out that temperature cannot reach 90 degrees anymore. Right? Okay, because there's some critical failure of the machine. Right? So we need to stop the process. Wait until they buy a new steam dryer that can reach 90 degrees, fix it, commission it, do validation, and then you can run back. If it takes 6 months, 6 months. That's how critical it is now. Okay, So now you are very confident with your HACCP plan dah create semua kan. Okay. So finally, actually not finally lah. This is supposed to be the first step lah usually. Okay, whenever a company wants to go for HACCP kan, first kita kena create HACCP team. Team HACCP ni, this is not a QC job tau, not QC job, not QA job. It's a multidisciplinary team from every different department. They can either do so. Why? Because you need an objective I, right? So, key reason, expertise and diverse knowledge. A cross-department team is different from different background, expertise and perspective allows a complete, comprehensive evaluation. So, sebab itu kita akan letak multiple department. Even though they have nothing to do with science or nothing to do with the science, they can bring from commercial because commercial will have idea untuk customer requirement. They can bring from safety because safety will have idea for safety, general safety operations. Okay, so the whole team must be a multidisciplinary team. Okay, collaborative decision making. So semua agree that this is the best way. Okay, so kalau letak production can just look at production side je lah. For them, production side maximizing production. They don't care about safety. They don't care about food safety. They don't care about raw material. And they don't care about customer requirement also. Right? So we need a multidisciplinary. So bila semua agree like, okay, yeah, this is what we need and this is how the safety is. And that's when they come up with the system. Hazard identification and assessment. Yep, okay, the HACCP team's first task is hazard identification and assessment. Okay, lepas you create a team, they need to sit down in a meeting, they need to go through the process flow and they need to come up with the HACCP. Actually, yes, their job. Okay, and establish a system to ensure implementation. So, kalau ada multidisciplinary team, okay, when you install implementation system, okay, they cannot tak nak ikut tak boleh sebab it's already agreed by a multidisciplinary team which contains every department. Production pun akan ada kat sana, commercial pun akan ada kat sana. Okay. Corrective action planning and continuous improvement. So in general lah, in normal health and safety, say in normal GMP facility kan, dia akan ada something known as HACCP meeting, food safety meeting, food safety team meeting. Depends on, sometimes once a month, sometimes once a 6 months, sometimes once a year, once a year ada.
And this that should be once a year.
CGMP I think it's once a month. CGMP is I think once a month lah. They get all the people come sit down, they will talk about all the food safety related issue lah. And then if they want to modify anything,
change the process, adjustment.
the reason why we don't do it here is because we have only too many meetings which discusses the same thing. Right? We have our Gemba meeting which we do every day, which also we talk about safety related issue. We have our weekly department meetings. We have our management meeting. Okay, so during our management meeting, you remember I always raise any product related issue or safety related issue, SM update safety SM related issue. That is actually a food safety meeting, pretty much. Okay. Too bad we discussed, but there's no rectification. Supposed to come up with a rectification plan. Okay. And then continuous improvement. Yeah, so continuous. That's why we do our weekly meeting, continuous improvement. So we try to see how we can rectify it. Okay. So in conclusion, HACCP is essential in food and feed manufacturing process to testing to ensure safe feed processing. Okay, you need HACCP to ensure safe food processing. Okay, always remember there's 7 key principles, right? That uses a science-based approach. Okay, and you begin HACCP system by creating a food safety management team. Okay, defining the process, you conduct the hazard analysis, and you define the critical control points. Okay, you create a team, create your process flow, you do health analysis, and you create a critical worker point. These are the four key main things lah. Okay. Understand everything? Yeah, that's about HACCP lah. Right? And this system kan is universal. You can implement this in any way. So if you understand the existing process, then you can work in any food industry or pharmaceutical industry or whatever industry that's related to GMP. In fact, the QA managers, right? Actually, I have my own group of friends who are also QA managers now, right? Different industry. One in medical device industry, one in pharmaceutical industry, the other one in the actual food industry. Okay. So we always have like a discussion among ourselves. What's the issues that we are facing here, and then how we can rectify this. So I always call them as well. I'll get advice from them. Like, okay, I'm having this issue right now. How do I solve it? And then sometimes they call me as well. Like, they are having this issue because certain industry can be an issue very unique to the industry now. Tapi the rectification process usually will be more or less the same. In fact, even today, so I just call my friend yang kerja dekat Secret SP. Dia kira macam Secret SP Johor ni. So I ada some issue to settle lah. Apa ada? Macam mana kita nak rectify benda ni? Yeah, it's a small community lah, I would say.
Dia nak kena macam jadi certified person ke kalau kita nak kata kita faham HACCP dan nak kerja juga lagi.
Yeah.
Yang certified.
So that's why we have discussed sekarang. Like I am I ada lead auditor for ISO 22100. Lead auditor. I'm a lead auditor. I ada lead auditor certificate for ISO 22200 for safety system. And I also have a training course, so that means I can train all of you in the food safety system and I can certify it. So since you all join here, now I will give you a certificate that you are certified as GMP HACCP. And you can use that as a sort of.
Kan certification dia memang like
Yeah.
okay.
Normally companies will do what they will call third party to come out lah.
No need exam ke apa macam tu?
Ni awareness lah.
Oh, wait,
Okay. Alright. So with that, we will try to end this assignment session. Hopefully, I was not too boring already. Do you guys have any questions? Apa nak clarify pasal HACCP? You can just okay. So for tomorrow, we will deep dive into Codex principles and the PRP. Okay. So how it's going to look like? Okay. So this is how our Codex document looks like. Okay. Codex Alimentarius, Food Principles, CXC 1-1969. Kita pakai revise in 2022. Tahun 2022 revision. The most latest lah. Okay. So under that, if you go through deep kan, you can dapat benda macam ni. 8.0, 8.1, 8.2, these are the clauses. So under this, like example, clause 8. So you notice right, I go to clause 8 now. There's no 1 to 7. So 1 to 7 is just introduction, like introduction and explanation. Clause 8 is PRP. So then primary production, what's the how they explain the data. Okay, and what we need to comply to. Okay, 8.1, 8.2, 8.3, 8.4, 9. Okay, so we will deep dive into the clauses. Okay. Alright. With that, I will end this session. We can see all of you. Okay. Bye. I can just say
Dah.
okay, apparently I kena buat an evaluation. Tapi I kena check dengan HR apa evaluation ni apa.